Welcome to the session. I hope you guys all had some time to get some caffeine this morning. And since you are here in the session, it means that you really are interested in the topic that we have. So my name is Thiago Almeida. I'm an integrations architect at Datacom. And I also work with Microsoft on occasion, helping them with proofs of concept for customers looking into systems integration. And most recently, I started doing some work on Windows Azure. And that's how I connected with Emil to work on a couple of projects like for Courier Post and other companies here in New Zealand. So the plan for today is Emil is going to cover some of the slides, and I will show you a demo. And then Emil is going to come back and continue on with the best practices that we've put together for you. So with that, I'll let Emil start.
Fantastic. So if you've been to the session last night that Tom Hollander did at 5:45 last night or something like that, it was the last session before the party. I understand it's unlikely that you might have been to that session, but if you were, it was talking about migrating applications to the Azure platform, and it was kind of covering the topic at breadth. Today, we are going to do something slightly different. It is somewhat of a sequel to that session that Tom Hollander did. And we are going to focus on a few more specifics. Obviously, we have a bit of a more specific scenario that we are going to look at in terms of migrating to the Azure platform. So what we are going to really talk about is understanding of what the hosting options for services, .NET Web Services, are when you start looking at Azure. We are going to talk about what the process of securing Azure hosted services is as well. And finally, probably the most important topic of the talk, or part of the talk, is how do you deploy actually a hybrid solution whereby probably the service itself runs in the cloud, and then there are some dependencies in the background that need, for various reasons, to remain as on-premises components. What a non-objective is for the talk is to talk about the business drivers and scenarios that would get a customer to start looking at Azure. That was addressed at Tom Hollander's talk, and I believe at a number of other talks during the event. The key takeaways is that hosting services in Azure is actually not rocket science, as long as you keep in mind the limitations and the subtleties that are present today in the platform. And this is what we are going to also talk about, what these limitations and subtleties are, so that when you start migrating services, you know about them, you don't get burnt. So the agenda, we are going to do a quick recap of the different .NET services and what the types are. We are going to talk about, or we are going to introduce what we call a canonical service implementation. This is our frame for the talk today, effectively. Then we are going to talk about what the migration scope is, and this is based on real-life requirements that we've heard from customers and engagements that we were engaged in. After that, we will see how the capabilities in Azure map to on-premises capabilities that we are all familiar with. Thiago is going to do a demo of a hybrid deployment, which follows pretty much the pattern that we are going to introduce in the canonical service. And then we are going to start focusing on the best practices learned from those engagements. This is just a very quick recap of what is available, and I'm talking still on-premises, what is available in the .NET platform in terms of different .NET service types that you can implement. You have SOAP, you have plain REST services, you have the data services, or OData, with a couple of different variants, RIA as well, and finally you have the workflow-based services that we introduced with .NET 4. So each one of these different service types comes usually with its own service host class in the .NET framework, and then you have a couple of hosting options as well. Either you can self-host, or you can host in IIS and WAS, possibly enhanced with Windows Server App Fabric in the on-premises version of that deployment. So this is just something to keep in mind, because you'll need to think about those hosting classes for the different type of services when you start deploying them to the Azure platform. We'll come back to that later on. So For a web service, what are the common capabilities that we observe in implementations? So the first one is identity providers and authentication. How do you identify who the user is? Then you have runtime hosting and security. Where does the service actually run and how access to that service is authorized? With App Fabric, Windows Server App Fabric, we introduced the caching feature as well. So if you have large reference data that you don't want to retrieve from the database every single time someone hits a service, you can put that reference data in memory, and then the service call can first check whether a piece of data is available in the cache. If it is, then get it off the cache, pass it on back without doing a round trip to the database or maybe to the ERP system, which becomes even more costly. File services, we are all familiar with that. Data storage and connectivity, the same thing applies. You have a database engine of some kind at the back end, and this is where you store your data. Integration to other services is an interesting topic. Thiago here is an MVP and a virtual technology specialist with Microsoft with BizTalk. So he has that topic well covered, and he's looking at Azure solutions from that perspective as well. And finally, something that is always at the back of our mind is the ability things like scalability and high availability in this case. So this is the canonical web service implementation, which, as I said before, we are going to use as a frame for our discussion. It may be overly simplified, but if we start covering every single corner case, then probably we'll spend talking about that topic throughout the whole event rather than just over an hour. So what we see here, right in the middle of this diagram, we have the actual web service implementation. And in many cases, it's not just sum 1 + 1 or 1 + 2 and return the result, which is completely independent calculation or processing. You need to go to a bunch of systems that you depend on. What we have in the diagram, we've included for completeness the web server, the Windows Server App Fabric cache as one of those dependencies. At the back end, on the right-hand side, we have the line of business application, things like SAP, JDE, all these applications. And usually we connect to those applications either through web services that they natively expose, or web services that are exposed by some kind of an integration product. And in our case, we assume that that integration product is either the fully featured BizTalk, or possibly if you want to go lighter weight, you can just go with the BizTalk line of business adapters, which is also a standalone component from BizTalk. Imminently, you are going to probably connect to some other dependent web services that provide certain functionality to your implementation. And then right at the bottom of the diagram, we have two different storage types, the file system and the database. Pretty familiar picture. So I talked about real-life requirements, which define the migration scope and the constraints for a migration. This is an important thing to remember, because this is what is going to drive some of the decisions and the recommendations that we are giving you for the rest of the talk. It's not the only way to do a migration, but considering these limitations and constraints that we need to work against, what we are telling you is very, very valid. So the goals: minimize amount of effort spent on migration. The expectation for people moving to the cloud is, I want to do it as quickly as possible. This is one of the premises that the cloud gives us. And usually people want to either maintain or improve performance. Some people don't necessarily need the high scale. They just want to offload a particular workload off their on-premises environment and get it hosted, so to speak, somewhere else. So another interesting topic is that people don't want to rewrite their code. This is important. In many cases, that code might have been written by contractors, by vendors, and you don't have complete control over the source code, or you don't understand necessarily how the whole thing works. So with minimal change, how do you move that service implementation to the cloud? Comply to government legislation and industry standards requirements. This is a very popular constraint that we have to live with, especially in New Zealand, where we don't have an Azure data center. So you need to go and host your data somewhere outside of the country. And for some certain types of data, this is a no-go. So how do you work around that? And can you actually still consider a deployment to the cloud? And the answer is, of course you can, if you know exactly what you are doing. What we are assuming here for the talk is that the system that you have on premises is capable of scaling out, in other words, scaling horizontally. Why we are assuming this? In many cases, it may not be true, but this is a well-known thing how to achieve for an on-premises deployment. So we are assuming that we don't need to cover that as part of this talk. So back to our canonical on-premises service implementation, when we start thinking of moving this to the cloud or migrating it to the cloud, there are a bunch of non-existing capabilities in the cloud that we should pay attention to. The first one is Active Directory. In a Windows environment on premises, we take identity and authentication pretty much as a given. You turn on Windows integrated authentication and everything automatically happens. For the cloud, it is not true. Active Directory is not necessarily there or readily available anyway. The second part is the integration capabilities. Line of business applications, take SAP for example, they are not certified to run in Azure yet, which means that they need to remain on premises. And with that, it means that you need to start thinking, okay, so if my web service implementation, or even at a broader topic, if my application that will eventually run in the cloud needs to interact with that backend system, how do I do that? What is that hybrid model that I should adopt? And in some cases, some of these capabilities and components may not be movable either. So a third-party web service that you depend on, you can't force the third party to move that web service. If the database has financial sensitive or personal sensitive information, we already discussed that there is legislation that prevents us from hosting that database in the cloud, so it needs to remain on premises, and you will be effectively forced into a hybrid deployment model. So what we try to do in this matrix, so to speak, and this is a bit of an eye chart, is try to map the on-premises capabilities to the cloud or Windows Azure features and capabilities. And we went one step further, which unfortunately we can't be completely accurate and prescriptive on, which is estimating the effort involved in moving components or a specific capability from the on-premises version to the cloud version. And this is a very coarse picture, of course. We have low estimated effort or medium or high. Right? I'm not going to cover every single one of these. The only ones that I'll point your attention at is the file services. Potentially, the file system doesn't really have a good equivalent, so to speak, in Windows Azure, and respectively, you'll need to think how to adjust your implementation to that if your web service is relying heavily on the file system. For a lot of web service implementations, this is not the case. At a broader level, at the application level, this may be true. You need to still think of how to, bridge that gap in the capabilities between on-premises and the cloud. But for web services, it's not that much of an impact. And the other one here, integration to other services and LOBs, I have low, medium there as well, and we'll see why. So starting from that service, what is the Azure version of the service going to look like? This is the mapping that we've done for our canonical service. So if you've noticed, with the transition, Active Directory kind of moved to the left-hand side into the access control service from Azure. The web service implementation itself is hosted in either a worker or a web role, and we are going to talk about some differences. The caching capability is now moved to Windows Azure Cache. The file system capabilities or file services, they can leverage either Azure Blob Storage or X Drive. We are not going to spend too much talking about that because it's what I would consider a bit of a corner case. Then we have the database moving to SQL Azure. And potentially, if you need to retain a copy on premises, there is a service as part of the Azure platform called DataSync. You can synchronize these two databases. For connectivity to LOB systems, and to other systems in general. We have the service bus feature or service in the cloud, which we'll actually spend quite a bit of time talking about a little bit later on. So I have some giveaways. Someone may say, hold on, there is a service in Azure called Azure Connect that enables to connect effectively Azure VMs, web worker roles, to the on-premises environment, and you can start consuming databases and LOB services that you have running in your on-premises environment. So that's represented by the two red and yellow arrows. Why are they not green? Any guesses? I have a pretty good, decent 16 gig memory stick here waiting to be taken. Why is it? Why is one of them red, connecting to web services, and the other one is yellow, connecting to databases, leveraging Azure Connect? Anything related to security? There is some security challenges, but no, security is not really an issue. Sorry? Not fully supported and released. A lot of services in Azure are not fully supported. Well, are not fully released, but we are still, building on top of these services. So no, this is not. Go on. We don't have much time. Yeah, go on. Performance. Performance is a consideration, but not. Okay, the memory stick stays with me until the next question. So the answer was the red color there against web services denotes the fact that a lot of web services on premises run in web farms for high availability purposes, and the service bus doesn't actually support exposing load balanced resources running in a farm on premises as a single endpoint that is consumable from the client in this case being the service running in Azure. So this is a no-go. The yellow color for the database connectivity relates to the same limitation that Azure Connect cannot connect to any kind of virtual IP fronted resources. And if you have a database, usually it is a database cluster, so it's a no-go. However, there is a workaround and the best practice that we are going to introduce a little bit later on, and that's why the color is yellow, not bright red. So with that, I'll pass the microphone to Tiago, and he's going to walk us through a demo implementation of that canonical service that he's built.
Okay, so the idea about the demo here is mainly to put in context what Emil has just been talking about, the canonical service. One of the things that you'll notice at the very beginning is that we have it spread out through layers or logical layers. And that's, I guess, the first thing to keep in mind is when you're developing your on-premises solution, try to keep it in different layers so that they can, once they are moved to the cloud, they can be scaled out easier. So in this case here, we have a presentation layer where there's a website for workers in the field and also at the company creating new jobs or tasks for the few people to go and do the work on. Potentially, you could also have an application for a handheld. Then on the business layer, there's a workflow that takes care of the job management or the whole life cycle of the job. At the services layer, we have an API, a RESTful API for the website to take advantage of. We have a normal web service to take care of the connectivity to the database and actually creating the jobs or making updates to the jobs. And then at the end, once the job is complete and we need to start the billing cycle, that's where BizTalk comes in because it'll provide the connectivity to SAP and the backend system. So as we start looking at moving to the cloud, these are some of the features that we can start taking advantage of. And we can start mapping, like Emil did, mapping what we had on premises to their cloud equivalent. So in this case here, for the presentation layer, it's going to become a website on a web role. Just as well, the workflow is going to be hosted on a web role as well. And you could also talk about the RESTful web service being hosted on a web role, but you can choose. So all the services here are being hosted on worker roles. And as you can see, all of those are taking advantage of access control service for its authentication and authorization. One other thing is that SQL Server database was migrated to the cloud using the SQL Server migration wizard, which analyzes your databases on-premise, looks at what the differences are from what SQL Azure supports, and then migrates the database for you. And lastly, we will keep some of it on premises, which is BizTalk Server connecting to SAP. I don't think anyone's migrated SAP to the cloud yet. So we will keep that on premises, and either you would open reverse proxy to your BizTalk server as you normally do nowadays, but now with Windows Azure Service Bus, it gives us some connectivity options that it provides sort of a relay between what's running on your websites on the cloud to what's running on premises at your backend systems. So with that, I'm going to switch to my demo machine. And we're just going to have a look at the demo. Okay, looks like it's all working. So I'll start by showing you on premises. I have here a full solution in Visual Studio. And it's been, as you can see, I tried to create it as the same types of layers that we saw on the website. So BizTalk server solution there, a workflow, the website at the bottom, all of the services combined together there. And you would use normal IIS to host those services and IIS to host the website, plus Windows Workflow could be hosted in Windows Activation Services, or most likely Windows Server App Fabric on top of that. So with that, I will show you the same solution with all of those services migrated to an Azure solution. So as you will notice, a lot of those same services in the same projects are here. We just mapped them to roles in a new cloud project. So we have the RESTful API running as a web role, and a couple of services running as a worker role. The workflow and the website also are their own web roles. So those can scale out and scale back down as required. So with that, the first point, the next point is to talk about access control service. So what I've done is I enabled this website and also the RESTful service to be secured by access control. So when I try to log on to the website, the first thing that I see is the sign-in page. And the options that I've chosen when I configured ACS are the options that you're given here. So if I go into Active Directory, for example, it'll give me a page to log in with my local Active Directory account into the website that's hosted in Azure. Otherwise, you can choose any of the other ones. So I'll go into here and log in. So with that, access control services is actually taking care of the whole communication with Facebook, Google, Windows Live. And then now it's showing that I'm logged in as myself. So for websites, especially public websites, you can take advantage of that quite easily. And I'll just show you the page on access control services. So here, as you can see, I have the website as a relying party. So this is where I configured the website to start using ACS. And also my RESTful web service is also configured to use ACS as the identity provider. The only difference is that ACS for the RESTful service is passing on a secure web token so that we can do it all via HTTP. The whole authentication goes over OAuth. And to show you, I just have an empty website here. And the steps to modify the website to start using Windows Identity Foundation and ACS are pretty simple. So this is the address that I'm given by ACS for my account. And I can just add an STS reference. I'll type in my URL. And I'll use an existing STS, so that's the provider that Access Control Services gives me. With that, it gives you some options for encryption and security. It gives you the provider identities that we want, or the claims that we want to use on our application, or the claims at least that ACS is giving this. And in the end, I can click Finish, and it's going to update. It's going to tell me that it's updated my web.config file. And we can have a look in there and see that it's now added quite a lot of identity-related items for my website. So if I scroll down to the bottom, we'll see that now when this website is meant to allow the user to log in, it's going to redirect to this. That access control service is going to go into the options that I selected there.
So the key thing here is that by effectively fronting our service with ACS, which is a federated identity broker, right, we are offloading the actual identity provider configuration to ACS. So now if we need to plug in another identity provider, whether it is Facebook, Google, or another Active Directory federation service, for example, it is just a matter of reconfiguring ACS rather than recoding our implementation. Really powerful model.
Yeah. So the next thing I wanted to cover is how we have more than one services being hosted by the same worker role. So if there are services that you believe that will scale out and scale back down together, you might as well share the same worker role and take advantage of all the processing power that you have in the worker role. So for that, here in the worker role, you can see that I'm making two calls. One is the job management service, and one is the job query service. And if I go into those methods, we can see that it's exactly the same hosting for your service that you have on premises. And the main difference here is that you have to map the external endpoints that Windows Azure gives you to the internal endpoints of the role. So this is what I'm doing here in these few lines. But other than that, it's exactly the same. One point that we want to cover, and I think Emil is going to cover it in a little bit more detail later, is this behavior here, the use request headers for metadata address behavior that you have to keep in mind to use, because your worker role is going to be spread across multiple instances potentially. And this behavior ensures that works out pretty well when you scale out and then back down, when you have an externally exposed endpoint like this.
So the thing here is that when the MEX request comes into a specific role instance of your web role or worker role, normally it would embed effectively the local name of that node into the WSDL that it returns back. And this setting effectively overcomes that and embeds, instead of the local node name, it uses the DNS name that the request came from, which is your public URL that fronts your role instances.
Okay, so I guess the next step is to show the Windows workflow handling managing the whole life cycle of this job. So I'll create a new job here. So I'll make a mechanics. It's going to fix my engine. Something is broken there. And I'm going to submit it. So that is meant to start a new instance of the workflow running on a web role for me. And after that, the workflow itself is going to create the job and then it's going to start expecting job updates to come through. So I'll go back there. So I created a new job for me, and I'm going to then go on and update the job status. So I'll say, so what number was that? 162. And I'll say the job's been completed. It only took an hour because the engine wasn't really broken, just needed some oil change. And with that, it's going to submit the update back, and it's going to go to the same instance of the workflow. And then the workflow is going to say, okay, it's updated successfully. With that, because we set it to completed, the workflow is the next step in the workflow. As you can follow here, if the condition is that the response type of the job status is completed, it's then going to go and call the billing process. So this is the next step that we want to cover, is to show the BizTalk server exposed through the service bus and this workflow running in the cloud taking advantage of that. So passing in the billing details to BizTalk to process into the backend system of the company. So this is where it calls it. We'll what we've done on the BizTalk server, so I'm going to change it to the on-premises machine, is that we have a normal BizTalk solution here. It expects the job billing. It's exposing a website, a web service. It'll validate the job, so make sure that there's enough hours, that it all computes correctly, and send back a response to the website. If it's valid, then it sends it to the billing, which is going to go into SAP. So with that, what we do is expose BizTalk server by running a wizard that creates an endpoint into the service bus for the locally hosted service. And you can do the same, of course, for any local web service that you have running on premises. You can expose that through the service bus. The benefit of this is that it creates a broker for you on the web for the web service that you're trying to expose. So you don't have to go through as much trouble as you used to in the past with exposing internal web services. It also gives you a sort of RSS feed for your internally exposed services, or that are now external. So here it's showing that we have the job management billing system being exposed through BizTalk.
So this is the public endpoint in the service bus that BizTalk, when the process came up, registered automatically through the binding in the service bus as an outbound connection. And that connection is now alive. It was established as an outbound connection from your network out into the service bus, right? And it is alive. So now if a request comes to that public service bus endpoint, right, it goes over that open connection. On your firewall, you only have outbound traffic. You don't have any inbound connections as such.
And from your client, as you can see, we have a max endpoint here. So the client, you just pointed at the max endpoint. It's going to treat it as a normal WCF service that you call. And of course, you can see we showed you that it's being hosted on the service bus. So the URL for this RSS feed is actually in the cloud under my billing account, or under my account. So I'm going to switch back to the demo here. And another part that we wanted to show, or that I wanted to cover, is the retry mechanism. So Nikolai yesterday on his presentation mentioned this, and it's for connectivity to database or Azure hosted resources, database, caching, the service bus, and the blob storage and all the other types of storage. There are small outages that happen, very small milliseconds, that you shouldn't consider as any downtime. So you need to treat those gracefully and continue and just do a little retry. So what the team, the customer advisory team, did was create an architecture for retries. So what I have here is the transient fault handling architecture from the CAT team. And I then take advantage of that from my connections to the database. So the website, of course, is going against the SQL database, SQL Azure database. And what I've done is I take advantage of those retry policies every time I try to connect to the database. So it handles that. My code doesn't need to know about it. It just goes and tries to run normally. And if there's any faults that it detects that are those normal Azure faults, it's just going to retry for me, and my code doesn't need to worry about it. The same happens for caching. So one good thing that I wanted to mention here is that the site itself, all of these lookup values, are being saved into Windows Azure caching. I'm running this from my local machine, but the actual caching service is in the cloud, and it's all looking up from the caching there and putting the values in the cache there. And that happens exactly the same as you do with your on-premises caching service from Windows Server App Fabric. It's pretty much the same code, so there isn't much that you need to change there. As you can see here, the only thing I did do is add the retry policy there when it's trying to open the data cache. From there, in my data access layer, you can see that it tries to get it from the cache. If it fails, then it's going to go to the RESTful web service and then try to get the data again. But if it doesn't fail, then we already have the results. So it's getting it straight from the cache, doesn't doesn't go to your database, and then reduces a lot of the connectivity to the database that you would have otherwise.
And it may not be just a database. It could be, connectivity to a dependent web service, which is completely external from your environment. It could be running on premises if it is delivered by a third-party vendor, for example.
And that would be very important to reduce the latency. If you have lookup values against something that's on-premise, then you just save those to the cache, and it would be a lot quicker to get it from the cache later on. And the final mention that I wanted to make is that you can also make this processing asynchronous, and it's something that you need to always keep in mind. I won't show it in the demo, but you could use what Emil's going to mention later on, topics and queues from the new Service Bus version 2 that's about to be released, and it's already in CTP. And when Emil covers that topic, I'm going to just mention or bring it back to this same demo and mention how it would be implemented in the demo scenario. And with that, I think we're going to go back to the presentation. Sure. Yeah, so that's a direct connection to the on-premises, so it is real time. So if that is down, then the client is going to get an exception as well. So in that scenario, if you do expect that to happen often, if your on-premises resource isn't very reliable, then I would consider going to asynchronous processing and using a queue on the Windows Azure queues, and then let that be the broker for the application.
Great, thanks, Tiago. Let's see if I can switch to the right monitor.
I think it was there. It's one.
That's okay, fantastic. Okay, so one last glance at what we saw during the demo. We saw integration with ACS, how easy it was to use the Windows integration Windows Identity Foundation wizard to connect our web service implementation with ACS. We saw how we can leverage Azure Cache. The API there is extremely simple. Azure Cache really exposes a couple of methods, get and put, and this is what you use to effectively store and retrieve objects of this cache. The Azure Service Bus, with its current released feature set, we saw how we can leverage the relay binding, which establishes an outbound connection into the service bus and registers an endpoint in the service bus. And then consumers of that service can start calling into that effectively brokered endpoint in the cloud without establishing a connection to your on-premises implementation. And we also discussed the transient fault handling framework for connecting to Azure Cache, for connecting to a SQL Azure database, and exactly the same pattern and functionality applies to Azure Storage. I'll explain a little bit later on what those transient faults are and why they are in the platform as well. So now we start covering the best practices and guidance for such migrations. The first one, once again, we are going to focus on the hosting options for our service implementation. The second one is securing the service with ACS. Third one, connecting to the database and migrating the database as well. And the fourth, one of the most important ones, is connecting to on-premises deployments or components in a hybrid deployment topology. So with that, let's start talking about the hosting options. There are a couple of things that I really want to mention here. The compute nodes in Azure come, as we all know, in two different flavors, the web roles and the worker roles. The web roles have IIS for web and HTTP bound workloads. The worker roles are a lot more generic. They don't have IIS, they don't have WAS. It is really up to you to implement and run your own process, so to speak. So in the context of services, when does it make sense to use web roles versus worker roles? The general guidance that I would give you is that normally if you have HTTP-bound services, the same thing extends to NetTCP, but generally speaking, if you have HTTP services, then probably you would like to think about hosting them in a web role. This is the easiest, painless option for getting your on-premises implementation and running it in Azure. If you have, however, workflow-based services, and I'm talking about Workflow 4, the better option is to host in a worker role. Why that is? Workflow services, in most cases, are there to implement a long-running process, which means that the workflow instances, throughout the execution of a single instance, have to persist to a database, and maybe based on a timer, some kind of delay, they have to come back to life and continue execution from the point where they stopped or started waiting for certain event to happen. In the on-premises version, we have Windows Server App Fabric to manage all this, to manage the installation of the persistence database for workflow services. There is a separate Windows service part of Windows Server App Fabric that manages the lifetime of durable persisted instances, and it kind of wakes them up if they need to wake up based on a delay, for example. In the Azure platform, that capability is not there yet. So you need to kind of do it yourself. And you can't do that in IIS because IIS, unless you hit the server with a request, it's not going to just load a process by itself. Yes, you can leverage the auto start feature that we introduced in IIS, but it doesn't actually load the process. It kind of prepares the app pool to serve requests. It doesn't mean that your service host is loaded. And the service host is the one that manages the workflow lifetime. So you need to have complete control over the service host lifetime, right, in order to deal with long-running, persistible workflow instances. And this is exactly what a worker role gives you in terms of, exactly when you instantiate the service host class, when you shut it down, and naturally you are going to do that just on role instance startup and shut down, so that effectively the instance lifetime becomes the service host class instance lifetime. And then any durable events will become valid and in scope of your process. Tiago already discussed the use of that special behavior, use request headers for metadata address. So I'm not going to spend any more time on this. And we'll move on to securing services running in Azure with ACS. A couple of points here. So the first one is that a service running in an Azure role runs under certain unknown identity. I don't really care what that identity is. If you need to protect that service in terms of authenticate and authorize, you need to access that service with an account, right? And if you do that through ACS, that account or user logon details effectively comes from a feature that is present in the access control service called service identities. Those are effectively credentials that you can use to securely access your web service. There are three flavors of service identities in terms of how credentials are provided. The first one is username password, so you can create a service identity in ACS that you go and retrieve a ticket for using a username password. Then the second option is using a symmetric key. And then the final one, and probably the most secure, actually the most secure one, is using certificates. So the consumer of your service needs to have a certificate in order to go to ACS, get a ticket for that service identity, and then pass that service identity ticket in order to access your web service running in Azure.
So just to put this in context with the demo, the RESTful service that we had there doing the lookups against the database, that RESTful service is secured by a service identity provided by ACS. So the client is the website itself. The website goes in, has the username and password, and then gets a token from ACS and passes that into the service, which is the RESTful service, that then validates the token and allows the connection to go through.
Cool. So one thing to keep in mind when you start looking at REST-based services is that for REST-based services, you don't have SOAP headers present. And this is what SAML tokens rely on. So using SAML is really not an option for REST-based services. This is where you need to go with simple web tokens, or SWT, that rely really on the HTTP authorization header as opposed to any SOAP headers and fancy stuff like that. And we covered pretty much the sequence depicted in the diagram. You have the application, which is the consumer. It goes off to ACS with credentials, requesting a ticket for the service identity. And we mentioned that there are 3 options for those credentials: username, password, and symmetric key and certificate. Then ACS would return the token, and then you pass the token to the actual web service implementation. SQL Azure database. So the first thing is, how do you migrate an on-premise SQL Azure database how do you migrate an on-premise database to SQL Azure? Got it right that time. So the easiest way, in our experience, I mean, there are a few options, and I'm not going to discuss all of them. I'll just give you the easiest option because we are talking about best practices and guidelines. There is a tool on Codeplex called the SQL Azure Migration Wizard. It is something that Microsoft actually put on Codeplex. There are a couple of folks that are very actively developing that tool and enhancing it as we are enhancing the platform, so it keeps up to date. It's not a dead project on Codeplex. Very nice tool for actually migrating on-premises database to SQL Azure. It generates the script from your on-premises database. It checks for consistencies in terms of syntax and features that your on-premises script has, and maps that, checks that against the capabilities of SQL Azure. It warns you of any discrepancies so that you can resolve them. But if everything is okay, then it will run that script to generate the target database schema in SQL Azure, and it will also BCP the data out of your on-premises database into files, BCP files, and then it is going to run BCP against your SQL Azure database and schema that was just provisioned by the tool and import that data. So very easy, painless exercise, as long, again, as the on-premises SQL schema and features that you are using are compatible with the SQL Azure feature set. I want to point out a couple of things that you should keep in mind when you consider migrating databases. The first one is that global temp tables are not supported in SQL Azure. If you have stored procedures that create global temp tables and do joins and things like this, they're not going to migrate very well. You'll need to rework a little bit that piece of your logic. So that's one of the common limitations that people face. The second one is the fact that SQL Azure doesn't allow cross-database joins, which is, once again, in T-SQL as well as stored procedures, quite a common pattern. What you will need to do in that case is merge your different database schemas from the on-premises implementation into a single database schema in Azure and remove those cross-database joins from your stored procedures and T-SQL. Consider the database size limitations. We discussed that in a number of sessions already, that the largest database size that you have supported in SQL Azure today is 50 gigabytes. We are going to increase that relatively soon to 100 gigabytes. But even if that is not enough, then there is a new capability coming out called SQL Federations that has been covered in a great talk by Chris Ode. If you haven't seen that talk, you can watch it offline or get the slides after the event. I would highly recommend that session, because this is where you actually start really scaling SQL Server horizontally, as opposed to the more typical approach for on-premises deployments to just grow the box. Cool. So Tiago already mentioned the transient faults that happen in Azure, and that does apply to SQL Azure as well. So use that framework that my team published to the web, to the community. It's very easy to use, as we've just seen from the code. I just want to spend a little bit of time talking about those transient faults. They are really micro outages in the Azure platform. It is a very complex platform. The fabric that controls those thousands of nodes of commodity hardware are smart to do two things. The first thing is this is commodity hardware, nothing fancy, and hardware faults happen all the time. We are talking about a scale of thousands nodes, right? So if 1 or 2 or 10 or 100 nodes go away, that's okay. The problem is that the environment needs to self-heal from those hardware faults. And it's pretty smart at how it does it. But if a node that was just serving your request goes away for whatever reason, then there are a few microseconds or milliseconds for that self-healing process to happen, right? Technically speaking, if you use the usual access patterns from on-premises implementations where you make one attempt and if it fails, you just raise an exception and bubble it up. That's a valid way of handling exceptions in on-premises applications because there are no such micro outages. In Azure, it is not really a fault as such. It is expected behavior, and you have to code for that through that reusable pattern as well. And then the second thing that happens in that complex environment is the fact that there is load balancing and reshuffling of computational power across the nodes all the time. If the node that was serving up my request gets really busy because there is hundreds of other requests coming in, Azure is smart enough to offload some of that workload to another node, but this is going to result in one of those micro outages. So you need to plan for that as well.
And there's of course, the other teams at Microsoft are aware of this. So like the Entity Framework team or the Patterns and Practices team. So they're looking at implementing the same type of behavior into their own products.
Cool. So Azure Connect. I want to be very loud and clear about this limitation of Azure Connect today. It does not connect to any kind of resources that are fronted by a virtual IP address. That impacts resources that are hosted on web farms, because you have multiple nodes with a network load balanced address in front. And it applies to SQL clusters as well, because you have a virtual IP in front of a SQL cluster. So if you need to connect to such resources on premises, especially for the first one, network load balanced farms, you are out of luck in the context of Azure Connect. For databases, you have one workaround that may or may not be applicable to you and what you can do with your application. So SQL has a very nice feature called SQL mirroring, which provides high availability, very similar to SQL clustering, but it is a completely different technology. It doesn't have a virtual IP address in front of it. It is two completely separate SQL nodes. One of them is primary node in the mirror relationship, and then the other node, well, primary, and the other one is a secondary node, right? That gets all the data or changes that happen on the primary node. If the primary node disappears, then the secondary node or the mirrored node takes over. There is no virtual IP address between the two. The way that the secondary node takes over the primary node in case of a failure in regards to the client is a trick in the connection string, in the OLEDB connection string. You can provide, apart from the server that you want to connect to, which is usually your primary node in the mirror relationship, you also provide a failover partner, which is the secondary node. So ADO.NET is smart enough to know that, okay, I just tried to connect to my primary node in the mirror, and it failed, didn't respond. I'm going to just automatically go to the secondary node, which by that time has become from secondary to primary. And this is depicted by this diagram on the screen that we have. So you have the two mirrors at the back, the primary and then the secondary on your right-hand side. The connection string is configured in the client with a failover partner. So under normal conditions, you connect to the primary. Everybody is happy. The primary disappears. Then ADO.NET, with the next request to the database, recognizes the lack of a primary node, and it connects to the failover partner, which has taken over in the meantime, and then everybody is happy. So this is an option for connecting to an on-premises database if you can switch from a cluster to a mirror setup. Not ideal, but something to know about and consider if you are talking to a customer or if you are deploying a new solution, for example. Don't go with SQL cluster, go with SQL mirroring. The second one is the SQL Azure Service Bus. So we discussed how a service provider, or our web or a web service, registers as an outbound connection an endpoint against certain URL in the service bus. And then this is the endpoint that clients start connecting to and invoking effectively the brokered on-premises service. Now, if your service is running on multiple nodes in a network load balanced farm at the back end, right? Each node, logically thinking, would register itself against exactly the same URL and endpoint in the service bus. And then the service bus is going to start doing the network load balancing across those different nodes that registered an outbound connection each. This is the bit that is not supported in the service bus. You can't register multiple listeners, which are the nodes in the on-premises implementation, against the same URI. Each listener has to be registered under its own URI. So this is a diagram that displays that. So you have the network load balanced resources at the back end. Each node registers an outbound connection. And the key here is that you can configure the binding on each node to register on a different sub-URL, right? This is what's depicted by endpoint 1 and endpoint 2. They're part of the root path, but they live at different endpoints right at the end. Normally, the relay binding from the service bus is capable of connecting to only one of these endpoints. You don't have network load balancing. You don't have high availability. So the solution is to implement a client-side proxy. And we have a sample of that in the SDK. A client proxy, which when the client starts, goes off and queries the RSS feed of registered endpoints in the service bus. It will retrieve the two endpoints that are registered by the multiple nodes at the back end because they live under the same root URL, so to speak. And then a round robin or a random invocation pattern, when you have a request to the service bus and to the backend service respectively, you can pick up randomly which one of those endpoints to call. So you are doing the network load balancing from the client. Now, this is an option if you can't redesign your web service. If you remember, I framed the discussion that there are goals of minimal impact on your code. This is minimal impact because the only thing that you need to do is introduce that network load balanced proxy, and then all the calls to the web service will start going to that proxy onwards. There is no conceptual messaging redesign as such, which leads us to the next topic. So if you do have control over the source code, and if you do want to optimize it for the cloud and turn it into a more reliable, robust messaging solution, then you can start leveraging the queuing solutions that we have in Azure. So we are talking about Azure Storage Queues. And with the CTP release of the Service Bus version 2, which will be RTMing relatively soon, we also have very true messaging semantics implemented as Service Bus queues. So now we kind of end up with two technologies. The Service Bus queues are a superset of the Azure queues. So if you are considering queuing, I would really advise you to go after the Service Bus queues, not really the storage queues. And the other extension or a new feature in the service bus is pub/sub messaging, where you can register what we call a topic, and this is pretty much an industry acknowledged terminology, a topic which becomes kind of the publishing location of messages from the client into the service bus, and then you can create multiple subscribers of this topic to receive the messages, whereby each subscriber has a filter criteria that determines exactly what messages published to the topic will be consumed by a particular subscriber.
So in our case of the demo, you would have a topic that would have receiving messages about updates to a job. You would have one subscriber that's a worker role somewhere that goes in and publishes those updates to the database, but also on premises or locally BizTalk server or other service would also have a subscription just on the jobs that were set to completed, and then map those into an internal process to do the billing. So you have two subscribers and the one topic.
In the interest of time, we'll take questions in just 1 minute. Let me cover this. So the final thing that I want to talk about in terms of redesigning your solution, if you have that control and luxury, is for compute-intensive processing. The CAT team released recently guidance for effectively a scalable architecture which relies on those asynchronous messaging patterns between the multiple compute nodes that your solution would have running in Azure. So you have one node on the top, which kind of serves as the controller. It manages the work. It pushes tasks or requests to queues. And in the first implementation of that architecture, we used storage queues. We changed that architecture to leverage the Service Bus version 2 features, specifically topics and subscriptions. So now the published version of the reference implementation looks a lot like this. You have the topic sitting between the different instances, and then you have multiple subscriptions of this topic, whereby each subscription has as a filter criteria the role instance which is supposed to receive the message, or that is subscribing to messages of the queue. And with that pattern, you have two message exchange patterns. The first one is multicasting, where you are not determining in the published message which instance you are targeting, and therefore all instances that have subscriptions of the topic will receive that message. Or alternatively, when you publish a message, you can say, this message is really targeting instance X, and then based off the subscription, it's instance X that is going to receive the message. Now, that guidance is available on our blog address, which is windowsazurecat.com. So in review, this is what we set out to talk about, and I hope and believe that we covered the topic pretty well. There is a bunch of related content. We are the last day of the event, so a lot of these sessions have already been. There is one coming, which is the first one, actually, DPR 302, migrating. No, did I mess it up? Which one was it?
It's COS 306, integrating the on-premises world with the cloud.
There we go. So Ryan Croker will be focusing on hybrid deployments. He will talk in a little bit more details about the service bus and topics and queues and subscriptions and all that kind of fancy stuff. If you are interested in that specific topic for hybrid deployments, then go and listen to him. I'm sure that he is going to do a great talk as well. With that, please fill out the eval forms, guys.
Yes.
This is how we know how well or how badly we did. I think that I hope that we did pretty well in covering the topic. And of course, if you have any questions, you can ask them now. I know that there is one at the back, but also will be available outside the room after the talk for about 5-10 minutes to answer any follow-up questions. So yeah, question at the back. So if I heard the question correctly, it's about your on-premises components connecting to Azure hosted components.
Yeah. So there's an API. Yeah. So it's just a Service Bus SDK that you download, and you use that to, and there's an API there that lets you connect to the queues that are on premises. All you need is the security key, name and key. Yeah, either that, or you can create a proxy in front of BizTalk that handles that. But in the future, we are looking at using, there's a binding that comes with the SDK that you can use that binding from a WCF custom adapter in BizTalk.
So with Service Bus V2, we introduced what will become the net messaging Service Bus binding.
Yeah.
And you can pretty much just reconfigure your service and client endpoints in an implementation to either consume or publish messages to Service Bus queues, topics, or subscriptions.
Yep.
Any other questions?
Great. And if you want to go into the details of what I had in the demo or look in the code with me, let me know. Just find me outside or My email is chiagoa@datacom.co.nz. And thank you very much for coming.
Great. Thanks, guys.